This video is on sigma notation. So sigma is a notation for sum of series, and it's this symbol here. This symbol is the sigma, and this indicates a series, and we're adding things together. And this here is an expression, and we sub values of r into the expression to get the terms in the series. So each term in the series is a different value of r subbed in, and the first value we sub in is whatever is down here. So r is equal to 1. So the first term in this series is going to be when we sub in r is equal to 1. And we do this all the way up to this number here. So r is equal to this number is going to be the final term when we sub it in. So in this case, it's going to be r is equal to 20. That's what we go up to. And you might be able to tell from this that r is basically n from before. If you replace r with n, it's the exact same thing, but it's usually wrote with r when we use sigma notation instead. So for this series, it will be, if we write out this series, so first of all, we sub in r is equal to 1. That would be the first term. So it's going to be 5 times 1 and then plus 2. So it's going to be 7. And then the second term is going to be when r is equal to 2. So therefore, it's going to be 5 times 2, which is 10 plus 12, which is, plus 2, which is going to be 12 like this. And then r is equal to 3 is going to be the next term, which is going to, if you sub that in, is 17. R is equal to 4, which is going to be 22. And r is equal to 5, which is equal to 27. And this goes on and on and on, all the way up to r is equal to 20 up here. And we can see that this is just an arithmetic series. And we know how to add together the terms in arithmetic series from the arithmetic sequences video we made before. So what we do is we just use the formula Sn, which is given to us in the formula booklet for an arithmetic series, which is Sn is equal to n over 2 of 2a plus n minus 1 d, like this. And therefore, we can just sub in the values of n, a, and d. A is the first term in the series, and we can see that this is 7. D is the common difference, and we can see that each time it goes up by plus 5. So 7 plus 5 is 12. 12 plus 5 is 17. So the common difference is 5. And n, we're subbing in all the way up to n to r is equal to 20. So therefore n is going to be equal to 20, as there's going to be 20 terms. We're subbing in 20 values of r, so there's 20 terms. So therefore it's going to be S20, which is equal to n over 2, so 20 over 2, of 2a, which is 2 times 7, plus n minus 1, so 20 minus 1, times d, which is 5. And if you put this into a calculator, is equal to 1090. So this here, the sigma from the sum of from r is equal to 1 to 20 of 5r plus 2 is equal to 1090. So here's another example. So we have this expression here, and then we sub in r is equal to 1 as the first term, then r is equal to 2, r is equal to 3, r is equal to 4, all the way up to r is equal to whatever this number is up here, so 10. So the series is going to be, so r is equal to 1 is going to be 3 times 2 to the power of 0, so it's going to be 3 as the first term. Then it's going to be r is equal to 2, so 3 times 2 to the power of 1, so it's going to be 6. R is equal to 3 is going to be 12, and then r is equal to 4 is going to be 24, and then so on and so forth. And we can see that this is a geometric series, and we know how to add all the terms together in a geometric series from the previous video, geometric sequences. So the way we do this is by using the formula given to us in the formula booklet. Sn is equal to a, and then 1 minus r to the power of n over 1 minus r, and then we just sub in the values for a, r, and n. So a is the first term, and we can see that that's 3, so a is equal to 3. R is the common ratio, and we can see that the difference between each term is times 2. 3 times 2 is 6, 6 times 2 is 12, it goes up like this. And then n is equal to this number up here, because that's the number of terms that we're subbing in. So n is equal to 10. So therefore S10 is equal to, and then we just sub in the values. It's going to be 3 of 1 minus 2 to the power of n over 1 minus 2, like this. And if you put this into your calculator, this is equal to 3069. So the sigma is equal to 3069 up here. And that's it. The series will always either be arithmetic or geometric, which we already know how to do. Sigmas is just a different way of writing it. What I would do, as I've done for these two questions, is to translate whatever the sigma is into the actual series and then work from there. I think it makes the problem a lot easier in this format. Now, really quick, to check your answers, your calculator is able to figure out sigma notation. So on your calculator, if you press Shift and then this X button on the calculator, it gives this blank sigma notation, and you can fill this in with the two sigmas we've done so far in order to check if we've got the right answer. It has x instead of r on the calculator, but it works the same way. So let's start with this sigma here. So for this first one, if you put 1 in as the x is equal to, and then 20 as the number on top, and then you put in 5x plus 2 as the expression and press equals, it also gives out the same value that we've got, 1090 here. You can put the x in the expression by using the x button here on the calculator. And we can do the second sigma example here by putting x is equal to 1, putting 10 as a number on top, and then putting the expression as 3 times 2 to the power of x minus 1 and pressing equals, and it also gives out the value of 3069. Now, I talked about this in the integration and differentiation videos when there was a similar technique using your calculator. If you get a question like this in the exam, you can't just put this into the calculator and then write down what the calculator says is the answer and move on, because the examiners are obviously aware of this feature and they will know you've done no work and you've just plugged it into your calculator. But what you can do is what we've done here. Figure it out normally with this technique using maths and a method. Then when you've got an answer, you can check using the calculator if the answer you've got is the correct one that the calculator gives out too. Now, just a couple more notes. Let's take the first example and let's do everything the same except make r is equal to 4 down here. So r is not equal to 1 down here anymore. So what this means is we instead start from r is equal to 4 by subbing that in instead of 1. So the series will be, so we start by saying r is equal to 4, so it's going to be, we sub in 4, so it's going to be 5 times 4 plus 2, which is going to be 22. R plus 5 is going to be 27. R plus 6 is going to be 32, and then so on and so forth like this. And we can see that this is the exact same series as this, but we don't include the first 3 terms here. Now, the way the book does this is by saying that the sigma from r is equal to 4 to 20 of 5r plus 2, so the sigma that we need to solve up here, is equal to the sigma of r is equal to 1 to 20 of the expression, so this is the sigma here that we've already figured out the answer to, minus the sigma from r is equal to 1 to 3 of this expression like this here. And this makes sense if you think about it, because this here is this sigma here, so it's going to be this series, so it's going to be 7 plus 12 plus 17 plus 22 plus 27, and then so on and so forth. And this sigma here is going to be, so it starts from r is equal to 1, so it's going to be 7, and then r is equal to 2 is 12, and then r is equal to 3 is equal to 17. So it's just going to be these 3 terms here. And we can see that because we're minusing this sigma here, these terms are going to cancel out like this, just leaving these terms, which is what's required in order to solve this. So the way that we would do this is solve these two sigmas individually and then just minus them like this in order to get the answer. However, the way the book does it, I personally wouldn't do it like this. The way that I would do it is by realizing that this here is just an arithmetic series where a, the first term, is equal to 22. D is equal to, and you can see that the common difference is still just plus 5. So D is equal to 5, like this. Now, N will not be equal to 20 anymore, as there is no longer 20 terms, because we're starting from R is equal to 4, and we don't include these first 3 terms here. So it's going to be 20 minus these 3 terms here. So N is going to be 17. Now, just to note, n for this series, it will not be this number minus this number. It's not 20 minus 4, because this gives 16, not 17, because we can see that it's actually n is equal to 17, as we only get rid of 3 terms like this. We only get rid of the terms when we sub in r is equal to 1, r is equal to 2, and r is equal to 3. R is equal to 4 is still included in this series, so just be careful with that it's going to be 17, not 16. Another way to think about this is n is going to be this number minus this number plus 1. And then if we do this, it's going to be, just with this here, it's going to be s, and it's going to be 17 is equal to 17 over 2 of 2 times 22 plus 17 minus 1 times 5. And if you put this into a calculator, it's equal to 1054. So this sigma is equal to 1054. Just one other note, I've seen a couple questions like this for a geometric series, and it references it a tiny bit on the spec. So this is the sigma that we talked about at the start with the geometric series, and this is a very similar question here, except it's got a +1 in the expression here. So we'll do as the same before, we'll convert it into a series. So when r is equal to 1, it's equal to 4, r is equal to 2 is 7, r is equal to 3 is 13, r is equal to 4 is 25, and then so on and so forth. But this is not a geometric series because it goes up by a different ratio each time. This goes up by 7 over 4, this goes up by 13 over 7, this goes up by 25 over 13. This is not a common ratio, so therefore this is not a geometric series. So this is a problem, and the question is, how do we do this? How do we deal with this? Well, what we have to do is we have to separate this sigma and this expression here into this expression and this expression. We separate it into the expression from r is equal to 1 to 10 of 3 times 2 to the power of r minus 1. So just this, which is actually this expression up here, plus the sigma from r is equal to 1 of 10 of this here, so just 1. You don't really need to put the brackets around it like this. And this is a lot easier. We know this part from before, this is just 3069, it's the exact same sigma here. And this second part here, you can see that there's actually no r in the expression here, because each term therefore is just going to be 1. So when r is equal to 1, it's going to be 1. When r is equal to 2, it's going to be 1. When r is equal to 3, it's going to be 1. It's just going to be 1 plus 1 plus 1. 10 times. So therefore it's going to be 1 plus 1 plus 1 10 times, so it's just going to be 10. So therefore it's going to be 3069, this sigma here, plus 10, which is equal to 3079. This is something specifically mentioned on the spec that you need to know in general, that the sigma from r is equal to 1 to n of 1 is equal to n. So the sigma from r is equal to 1 to 10 of 1 is equal to 10. So just be aware that the sigma could split like this, and you might need to know knowledge of something like this. So here's an example question where we need to go from r is equal to 1 to 25 for r minus 3 for the sigma. So as I said before, you should always translate it into the series, as in my opinion, this makes it a lot easier to work with. So to translate it in the series, so when r is equal to 1, it's going to be 1 minus 3, so it's going to be minus 2. When r is equal to 2, it's going to be 2 minus 3, so it's going to be minus 1. When r is equal to 3, it's going to be 3 minus 3, so it's going to be 0, and then plus 1, plus 2, etc. And it goes on and on like that up to r is equal to 25. So we can see from here it's an arithmetic series where a, the first term, is equal to minus 2. D is equal to 1 because each time it goes up by plus 1. Minus 2 plus 1 is minus 1. Minus 1 plus 1 is 0. And n is going to be the amount of terms, and there is going to be 25 terms because it's subbing in up to r is equal to 25. So n is equal to 25. So therefore we use the formula for an arithmetic series, Sn. Remember, this is given to you in the formula booklet. It's going to be S25 is equal to 25 over 2 of 2a, and a is minus 2, plus n minus 1, so 25 minus 1 times d, which is 1. And if you put this into a calculator, it's equal to 250. So this here is equal to 250. So here's another example, this time where r at the bottom is not equal to 1, it's equal to 5. Now you can do it like the book does it, of doing the two sigmas and minusing them from each other, but the way that I would do it is just by figuring out the series. So we start from r is equal to 5, so translate it into a series, so it's going to be 2 to the power of 5 minus 2 as the first term, which is going to be 2 to the power of 3, so it's going to be 8, and this is going to be plus, and then r is equal to 6 is going to be 2 to the power of 6 minus 2, so 2 to the power of 4, so it's going to be 16. Then r is equal to 7 is equal to 32, r is equal to 8 is equal to 64, and then so on and so forth. So here, this is a geometric series. We can see where a, the first term, is equal to 8, and r is equal to, you can see it goes up each time by times 2, so therefore r is equal to 2, and then n is equal to, so remember, be careful with n, it's not this number minus this number because we include the r is equal to 5 here. So what it's going to be is the amount of terms, and this is going to be 12 minus 5, but then plus 1 onto the end to compensate for that. So it's going to be 12 minus 5 plus 1, which is going to be equal to 8. So now we just sub everything into this formula here. So remember, this is given to you in the formula formula book, it's Sn for a geometric series. It's going to be S and then n is equal to 8 is equal to a, which is 8, and then 1 minus 2 to the power of n, so 8, and this is over 1 minus r, which is 2. And if you put this into a calculator, this is equal to 2040. So this sigma here is equal to 2040. And again, you can remember to check these in your calculator by putting the sigma into your calculator and using that method. It's a really good way to check. Sigma notation wasn't something covered in the old spec, so there's only one more question in this video and you can find more in the textbook. So here's a question on sigma notation, so pause the video, have a go, and I'll go through the answers in about 5 seconds. So we have this function here for r, and it is equal to gr plus h, and it is the expression in both of the sigmas, where this goes up to 10 and this goes up to 20, and this is equal to 160 and this is equal to 720. And we need to find the values of g and h here. So first of all, as I said before with sigma questions, I would always translate the sigmas into the actual series and then work from there. So when r is equal to 1, they both start from r is equal to 1, it's going to be g plus h. I'm going to put brackets around it to show this is a term. And then when r is equal to 2, it's going to be 2g plus h like this. And then the third term when r is equal to 3, it's going to be 3g plus h, and then it's going to go on and on like this. And we can see that this is an arithmetic series because it goes up each time by plus g like this. The h's remain the same, and the only thing that changes is g and 2g. So g plus g is 2g, 2g plus g is 3g, so it has a common difference, d equal to g, and a, the first term, is equal to g plus h, and this is the case of both sigmas. Now let's focus on the first one here. So n here is going to be equal to, because we're going up to r is equal to 10, it's going to be equal to 10. What we can do is use this formula here and equal this to 160 and then rearrange from there. So it's going to be, so as it's n is equal to 10, it's going to be s 10 is equal to, and then it's going to be n over 2, so 10 over 2, of 2a, so it's going to be 2 times a, which is g plus h, plus n minus 1, so 10 minus 1, times d, which is g like this, and this is equal to 160. So this is the case here. We can do some rearranging. So 10 over 2 is equal to 5. We can expand this bracket here to 2g plus 2h, and this here is 9, so this is just going to be 9g like this, and this is equal to 160. Simplify this to 5 of 11g plus 2h is equal to 160, and we can divide both sides by 5 to get 11g plus 2h is equal to 32. So we have one equation here, and we can create another equation here to create simultaneous equations which we can solve from there. So here, n is equal to 20 instead. A and g are still the same, and then we can sub it into here. So it's going to be s20, I'll do it down here actually, s20 is equal to, so it's going to be n over 2, so it's going to be 20 over 2 of 2a, so this is still 2 of g plus h, plus n minus 1, so it's going to be 20 minus 1 times d, which is equal to g, and this is going to be equal to 720. What we can do is simplify this, so 20 over 2 is going to be 10, and this is going to be 2g plus 2h. If we expand the brackets, 20 minus 1 is 19, it's going to be 19g, and this is going to be equal to 720. And then we can simplify this to 10 of 21g plus 2h, which is equal to 720. Divide both sides by 10 to get 21g plus 2h is equal to 72, like this. So now we have two simultaneous equations. 21g plus 2h is equal to 72, and 11g plus 2h is equal to 32, and we can solve these two simultaneous equations by whatever way you want. The way that I would do it is just minus this one from this one, because we have the two h's here which will cancel out, to just leave 10g is equal to 72 minus 32, which is equal to 40. So therefore g is equal to 40 divided by 10, which is equal to 4. So g is equal to 4, and therefore we can figure out h easily by just subbing g into one of these. I'll do it into this one. It's going to be 11g, which is 11 times 4, plus 2h is equal to 32, which is going to be equal to 44 plus 2h, which is equal to 32, and then move the 44 onto the other side to get 2h is equal to minus 12, and then h is equal to minus 6. So g is equal to 4, and h is equal to minus 6. And what you can do is you can sub the g and the h values into this formula here, and then make these two sigmas here. This one should give out 160, and this one should give out 720.